going to need your calculators out, Bondi. And your calculators out, guys. Pardon? Right, so basically what we need to do to finish this off is we've got lots of fractions. We've got lots of fractions and we want to be able to write them in a different way. I say that word way, but what I should be saying is what? So a fraction or a decimal or a percentage are numbers written in a different. So 0.5 is the decimal equivalent of 3 over 6, or 26 at 52. But we also say these three are different watts page of the number. Begins with F.
Factor. Decimal. It begins with F.
No, that is fraction. Fraction is a something of the number. Decimal is a different something of the number.
No, it begins with F.
It's form. Remember, that's the concept we've been working
I
with.
said that.
Right, form. So let's just convert. All right. How do you convert? Well, we've got 0. We've got the 0.550%. We've got the 1 and 100%. How do I convert these into decimals? So yours is not going to be the same as mine. So don't copy. If your fraction is different. But how do we actually do it, Paige?
You divide 1 by 24.
Good. So we're going to do 1 divided by 24. Right? That gives me. Can someone do that for me?
No.
Yeah? What is it?
It's 0. Wait, hold on.
So I don't think it's going to work.
It's
I'm going to share it in the calculator because Laura's not so good at that.
0.04166666.
0.04. Should we round it to that?
Yeah.
Okay. So the next one for me would be 1 divided by 12. Could you tell me what that would be?
Wow.
0.08. We'll round it to that. Bondi, you can tell me the next one. What's 1 divided by 8? It's 1.
I just found it.
0.125. Okay. All right. What do you think about those numbers? Do you think I've gone close enough to 0.5 to actually have them in the unlikely but almost evens? Or do you think they're still all about the very unlikely area? I would agree, actually. I don't think we've got close enough to the 0.5, and it's easier to see when it's in a decimal look. Yeah? Right. How do I turn those numbers into percentages? Hazel?
You have to multiply them by 100.
Okay, so I'm going to do 0.04 multiplied by 100, and I get 4%. That's a nice variant, actually. The next one is
8%.
8%. And then I've got,
Well, you don't really have to do that because you can just like move them up.
which is the same thing as multiplying by 100.
Yeah.
That is just a way of explaining what it looks like you do. It's how to multiply by 100. It's not multiplying by 100. It's not doing something different. It's just multiplying by 100. It's just a method to show you how to do it. Go for it. 12.5%. Now, can you see from that, look, that's even easier to see, isn't it, that we haven't got anywhere near 50% for our just a little bit unlikely, have we? We're quite a way off. So really, we could do with changing a couple of these. We're still in the very unlikely regions, aren't we? Right? So can I get you to fill in your grid then? Finish off whatever numbers you've got. Fill it in with decimals and percentages. Make sure you've done all your notes. Right, let's have a look. You are playing an adventure video game. It takes place on the Greek island of Crete. You're at a point where you can take a bus or a taxi to a small town of Calabriani. From there you can walk or cycle. Okay. Now it says each possibility is equally likely. Make a tree diagram. So hopefully, what sounds like people have been all right with the tree diagram, because we start and our first pair of options are
Bus and
bus and taxi. So we've got bus, taxi. Now, both of those things go to the same place, yeah? So the next trip, so that takes us, what's that? That's the Calabriani. So we're there now. The next thing is we need to get to the beach. And the options for beach are
cycle or walk.
Cycle or walk. Now, cycle or walk can happen if we put the bus, so we can go cycle or walk. But it could equally be taxi, then cycle or walk, right? Did on purpose to see whether you noticed.
Good.
This is
I know.
Alright, so now here's the bit that we're not quite up to yet, but we're getting there. This is why I've given you the wrong question, but we'll go through it. It says in the question, make a tree diagram. It says each possibility is equally likely. So, and I think that's why they've said it's a computer game, not real life, because really in real life it's not equally likely. So what is the probability that this person playing the computer game chose to get on a bus?
Well, it's half and half.
50%. 50%. So it's 1 out of 2. Yeah? What's the chance of taking a taxi? 1 out of 2 possible options. Yes, exactly. In real life, the chance that well, there might be lots of taxis there, but they're expensive, and buses are cheap, but there's one every hour. In Bermuda, they might even turn off. So really, but that's why it's a computer game, so we can ignore all that page, can't we? Just like you're doing to me now. Page is ignoring me, and that's on the video. Alright, so cycling, again, is 1/2, 1/2, 1/2, 1/2. Yes, Rory?
I was going to say, I don't think, even if it was in a video game, it would be equally likely. I do think there would be different places.
That depends how the game has been set up. If you're doing something like a game where you don't pay at all and you just jump in the nearest thing and it takes you, then, you know. It's a simplified version. So simple you don't even need to write it down, I've noticed. Alright, now this is, that bit's no difficult for you, is it? Alright, that's easy enough. Tree diagram, writing, the next bit is something we haven't done yet. So now we need to know, what is the probability, what did he say? Find the probability that you will take the bus and then walk. So the option on the tree diagram, so we start our journey and we get on the bus and we then walk. Right? That's what I'm looking at. Now, what's the probability that I take the bus and walk? So we've got bus and walk. Now this is where we have an interesting, this word in probability, girls, come on. You shouldn't be talking over me. The bus and walk. Now the word and, Bondi, means something specific in probability. Alright? Rory.
I think it would be 2 out of the 3, out of the 3
isn't it 1 out of the 4 options?
No, so it would be, no, but what I mean is, so you would have to choose bus over taxi, which
Yeah.
had to get you to 2. So when you choose bus, you go, like, you take the bus, you get dropped off, and let's say there's a bike next to you, you can choose walk or cycle. And when you choose walk, that's the second option, so you've chosen 2 out of the 3.
Right, so
out of
no,
the 4 different
the thing is,
One
it
out of
says the probability that you take the bus and walk. You'd be right if you were saying, what's the probability that he walked to the beach? We'd then have to consider the other one as well. But I don't consider this route because we know he did not take the taxi. Yeah?
I'm not, okay, yeah.
Yeah? We don't consider this walk because it's not bus then walk. So the probability that he decided, because it's all the same probability, the probability that the bus then walks is obviously 1 out of the 4 options. Now here's the important bit. Bondi, you're annoying me now. Alright, and the next thing is I'm going to put it as a notification on management. Yeah? If I have to go that route, I will. Because everyone's doing so well, but you don't do well in this group if you don't pay attention. You just be silly. Alright? You have to focus. Focus, everyone will do really well. Alright, now let me just introduce you to something. This word "and" in probability is for multiplication. Alright, so what we can do to work this out, this is 1/4, 1 out of the 4 options, but we can show that is true by doing the 1/2 for the bus, 1 out of 2, and then we multiply by the 1/2 for walking. And what is 1/2 multiplied by 1/2? It's not, that would be adding. It's 1/4, actually. Maybe that's something we need to work on, but it does work. Alright? So we do get the same answer, but it's 1 out of 4. Yes?
The reason it's a quarter is because 1 times 1 is 1, and 2 times 2 is 1.
Yeah. Another way, if you don't quite get that, is remember what the word for multiplication was? Well, in probability it's "and", but in just basic probability it's...
And what you do to the bottom and you do to the top.
That's equivalent. That's not doing the multiplication, but good that you've remembered it. For equivalent fractions you do that. Yeah?
What I do is I just do, because 1/2 is equivalent to 0.5,
Okay?
and then I know that 5 times 5 is 25, so it's 0.25, which is the same as 1/4.
50% times 50%. Now, the thing that I'm asking you to remember is what is a word for multiply. When you first started your multiplication, if I said to you, and you don't need to write this bit down, so don't worry about it. If I said to you, what does that mean? If you had to explain it to someone. Right, I remember last year I said we're not using the word, well 2 years ago I said we don't use the word times anymore. We use multiply, or we say it in a different way. Yeah?
It's 2, 3 times.
No
Two.
times?
2 multiplied by 3. 2.
How do I explain it to someone? What did you say, 2? No, that's division. And that we shouldn't say over either. So, but that doesn't explain to someone. So for instance, if I got you to draw a diagram, you would do like that, yeah? And then do it again. And then do it again. Because you have
2 and 3.
what?
2 and 3.
You don't have 2 and 3, no.
2, 3.
Overcomplicating it. It's just a couple of words.
So, to explain 2 times 3, so timesing is when you take a number and you add it the amount of times that you're
Yeah, so what's the easy way of saying that? I've got, if I do have 3, I've got 2 added to 2 added to 2, yeah? If you remember, guys, that means 2 lots of 3, yeah?
I thought
Well, I would hope you did learn it with Miss Garnett. I hope you learnt it in P4 or whatever when you started doing multiplication.
We did do lots of.
I don't say lots of anymore because I hope that you know what that means, yeah? That's why I'm saying all the way back, and now we just assume you know. But the reason why I bring you back to this, guys and girls, is because 2 lots of 3. You know it means I have 2 lots of 3, yeah? 2 lots of 3. Or 3 lots of 2. Now the reason why I say that is because then this makes sense. This could be half of a half. And what is half of a half? So if we were to do it in the same way, look, half of another half lots of, right? Half times a half. Well, that means, let's say I have a cake, right? Here's my cake. But I only have half the cake. And if I say, well, now I only get half of the half of the half is what? A quarter, right?
Oh yeah. This is got a lot of
Half of a half. If you have a cake, and I give you half the cake, and then I say, actually, out of that half a cake, you're only allowed half of that, right? You'd have a quarter of the cake, wouldn't you? So that's, and if you have half of a quarter, yeah, half of 1/4 is 1/8.
Nope.
Half of 1/8 is 1/16. So you'll spot the pattern. Right. Okay. Back to the probability. So we have answered that question. Right. So actually, sorry, I messed up a little bit, but what I would like you to do now is let's take a step back a little bit, and I want you to do. We've kind of done this with our table already. Kind of done this already. So let's go on to question 2, which is represent. So this is where we're at the moment, understanding about what the numerator and denominator means. You are creating rules. But we'll do that next time, because what we can do now is leave the okay. This is called higher and lower. Now, let me just make one thing clear. If we're not participating, if we're just staring into space, or we're not doing it, then it's not worth doing. Okay? All right, I am still recording, so it'll be on the video, but I just wanted to explain to you how you play this. So this is about probability, but it's another game. It's gambling. It's not great, but we shouldn't really gamble. But we've got 100 tokens. All right? We've got 100 tokens. And we're given a 4 of hearts. And basically, we have to decide how many tokens I would like to bet on whether I can get it correct, whether it's higher or lower. The next card, is it higher or lower than a 4? All right. So, for instance, if you think the probability of it being higher is really good, really high, you would maybe bet a big amount. If you think, oh, it's small because there's not many cards, you wouldn't bet, you wouldn't bet a lot, just in case you get it wrong. And sometimes you'll think, oh, how am I supposed to know? So I'm going to ask you at the end when we do this whether how you make your decisions. All right? Right.